Welcome to Pre-Calculus Concept 31A. We're going to be looking at some new trig identities that involve the cosine of a sum or the cosine of a difference of two angles. As we talked about in class, you will not have to memorize these formulas, but you are going to have to be able to recognize and use them in an appropriate problem. First one, cosine of alpha plus beta is the following combination: cosine alpha times cosine beta minus sine alpha sine beta. So again, now that you have your toolkit sheets, you should add this formula to the list. And then right below that, you have a very similar formula for the cosine of the difference of two angles. Alright, let's look at an example. These formulas basically allow us to add to the list of angles we can find without your calculator. So our first task here is to think about how I could come up with the cosine of 15 degrees by thinking about 15 as either a sum or difference. So it turns out that if we think about a 45-degree angle minus a 30-degree angle, that in fact would be 15. And I picked those two angles specifically because 45 is one of our special angles that you guys know from your unit circle, as well as 30. Alright, so using the formula from the other sheet, I can jump right into what this formula would look like. It's going to be the cosine of 45 times the cosine of 30. Those are degrees, right? And then plus the sine of 45 times the sine of 30. So the formula basically allows us to think about the cosine of 15 degrees related to these other angles, 45 and 30. Okay, each one of these I know individually. Again, pull out your unit circle if you need to, but at this point you should know these pretty well. I'd have the square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. And the sine of 45 is the square root of 2 over 2. And the sine of 30 is a half. Multiplying these out, I get the square root of 6 over 4 plus the square root of 2 over 4. And since you have a common denominator there, you can write your final answer as the square root of 6 plus the square root of 2 over 4. Be careful, you can't do anything with the numerator there. The only way you can add square roots is if you have the same number inside the radical. Alright, you try. Your first task in here is to think about 75 degrees in terms of angles that you already know. So take that hint, use your formula, and see if you can come up with the cosine of 75 degrees. Alright, hopefully you noticed that 75 was the sum of 45 and 30. And because of that, it's a lot like our last problem. The formula is very, very similar, except for a difference in the minus sign in the middle. So using the right formula and simplifying your answer, you should have gotten the square root of 6 minus the square root of 2 over 4. Great time to use your calculator as a check, but again, for these problems, we're expecting you to use the formulas and not just simply type in cosine of 75 and get a decimal answer. Alright, another example here. I've got a expression involving the sines and cosines of 80 and 20. And the trick here is to recognize that this is once again one of the formulas from this section. And if you have your sheet in front of you, you should kind of recognize that this entire expression is the same thing as the cosine of 80 minus 20. Right? So we want to basically understand these formulas in both the forwards and backwards direction. Once you recognize that, we can simplify it to cosine of 60, and that's a value that you should know. Once again, from your unit circles, the cosine of 60 is 1/2. Okay, so again, understanding the formulas from this section, both forwards and backwards, is expected, provided you have the formulas right there in front of you on your toolkit. Okay, try this one. Again, this expression here is going to be able to evaluate it using your formula toolkit sheet. Okay, hopefully recognize this as the cosine of 70 minus 40, and that is a value that you can work out from your unit circle.